Hello everyone, thank you for joining us in another one of our Lab Chart Mastery series of webinars. My name is David Ream. I'm the Technical Support Engineer for AD Instruments North America, and I am based out of our Colorado Springs, Colorado office. And today we're going to cover calibrating your respiratory flow and using the Spirometry extension. And here is the upcoming bullet points, I guess we could say, for our webinar program today. First, we're going to cover hardware setup, the different types of hardware you can use, things you need to take care of prior to recording with your hardware. Next, we'll talk about software setup and pneumatic calibration. And finally, we'll talk about the analysis features available to you with the Spirometry extension. A word to the Spirometry extension: since it is an extension, it is free to all LabChart users, so you don't need a LabChart Pro license code to actually be able to access and use the Spirometry extension. So that's what we're going to cover today. So I'm going to go ahead and move on and kind of exit out of my presentation and open up LabChart. So before we get into software, as I mentioned, we're going to talk about some hardware concerns. So obviously the Spirometry extension is designed to be used with a spirometer. We market a variety of them, both a spirometer, a research grade spirometer, front-end amplifier, as well as a spirometry pod mainly designed for teaching use. Today I didn't have access to an actual spirometer amplifier, so we're going to be using one of our teaching grade spirometry pods. So first thing, and one of the most common pitfalls for excuse me, for our customers is not allowing the unit either sufficient time to warm up or actually zeroing the spirometer before collecting data. If you don't allow it the proper time to warm up or don't zero before collecting data, you'll quite often run into the drifting volume calculation that many people who have performed spirometry before run into. So a word to the warm-up. Normally we recommend about 15 minutes of warm-up before using the spirometer or collecting any data. And normally what you want to do is go ahead and connect your spirometer to the power lab, turn on the power lab, start the software, and just kind of let everything sit there and run for about 15 minutes, just not really collecting data, but just sitting there with power applied. The reason for this is most electrical equipment is designed to be run at its operating temperature. And if you kind of jump the gun and start collecting data right after starting everything up, it may have not reached its operating temperature, and you're going to see some thermal drift in your signal or an offset. This offset, usually on the flow channel, can just compound problems further down the way, as I mentioned before, in your volume calculation channel. So I've had my spirometer connected here, warming up for about 15 minutes. And once we've kind of reached that, we want to go ahead and zero the spirometer. And like I said, this will also take care of any of the offset problems that can occur in the flow, which in turn cause even worse problems in the volume calculation. So you can zero your spirometer one of two ways. The first is to actually go to the Setup menu. You're in Lab Chart. Go down to Zero All Inputs and click that. And that will zero your spirometer as well as any other amplifier that's connected, or just basically zero all of the inputs that are actually going into that, coming from that power lab. The other way to do this is through the spirometer channel calculations dialog. So I'm going to go over here. My spirometer is connected to channel 1. We'll go here to channel 1, and you'll see here we have spirometer pod showing up in the channel calculations menu. If we click on this, we bring our spirometer's settings window will come up here, and you'll notice that right here we actually have a zero option. So you can see here in my spirometer that I have connected, we're actually seeing a little offset here. And this offset can be, like I said, the root cause of a lot of problems later on down the line with the spirometry extension. All is not lost if you don't zero, but it can be, at times it can be very difficult to go in here and actually change, remove that offset via the other features in LabChart. So it's always better to take care of it right off the bat and get things zeroed. So I'm going to go ahead here and zero my spirometer. And actually, let me back up a little bit. Prior to zeroing, you might want to make sure that you're recording at the proper range for your flow head. Or if you're using a third-party spirometer, be sure that you're recording at the proper range for that. Later on down the line, we'll talk about detection settings for the spirometry extension. And if you are using too large of a range, so your actual max signal amplitudes are significantly lower than the actual range that we're recording at, we can run into identification problems with the spirometry extension. So normally we recommend whatever your anticipated max amplitude is, we want to have the range slightly above that, like the next setting above that. That will allow you to see all of that. So if you're using a third-party spirometer, chances are you're going to have to kind of go here and record some flow data, bring it in and see, okay, yeah, we're well over 50% of the total range. That should work well. Or we're under, so we need to drop our range down a little bit more. Normally with our front ends and the extension, everything works pretty well, but it's always good to go in and validate and make sure we're recording correctly. So that kind of takes care of what we need to be concerned about with hardware, both with warming up and also zeroing. So that's going to take us on to actually recording data and some calibration steps. So I am going to open a file here. We'll go down to about 4 channels. That's all we should need. And this file is actually recorded with actually using a two-way respiration circuit. So both inhalation and exhalation are going through the flow head. You do not have to use a two-way circuit with a spirometry extension. You can use a simple one-way circuit where either inhalation or exhalation are going through the flow head. A word to the flow head orientation and expiration. The spirometry extension, the algorithms it uses to actually determine a lot of its calculations, it requires you to have the exhalation actually make a negative deflection in the flow channel. So if you're coming up with really strange tidal volume numbers, things just don't seem right with what spirometry is actually calculating, double check that, and that can definitely cause problems, especially if you're using a one-way circuit and you're just saying, okay, well, exhalation is actually a positive deflection. So once again, ensure that the way your flow head is oriented, that we're actually getting a negative deflection for expiration from the subject. So once we kind of talked about the flow head orientation here, we're going to talk about setting up the flow channel. So as I said, my spirometer is actually connected here to the flow channel in channel 1, excuse me, and we're going to go ahead and actually record a simple flow calibration here, a word to calibrations. The spirometry extension actually has predefined calibration values for every flow head that we market. So anything from the MLT 1L to the MLT 1000L. We also offer our heated pneumotac that's manufactured by Hans Rudolph, the MLT 800L. We have predefined units conversion and calibration values that will take you over from voltage 2 liters per second. Now, that may be fine for the education setting, but as a researcher, you might want to have something a little more accurate. And to that end, we actually market a 3-liter calibration syringe. It's known as the MLA 5530. That allows us to inject a known volume through the flow head, get a nice flow response from that, and then in turn calculate the conversion values for our flow head. Do you have to use the MLA 5530? Not necessarily. Obviously, it's going to be a little difficult to use with our smaller flow heads. We may kind of go out of their nonlinear range. But if you do have something that allows you to give a very accurate known volume, just discharge that, you definitely could use that. So we're going to go ahead and record a flow calibration here with a syringe. So you can see here we're injecting. I'm going to go ahead and stop and auto scale. So we have our flow head set up correctly. We're basically forcing the known volume through the flow head as if it's an expiration, and it's shown right here. Now we can go ahead here and select this region by left-clicking and dragging with our mouse. And we're going to go ahead to our channel drop-down menu by left-clicking the channel title bar. And if the spirometry extension is installed and turned on, you'll get these 4 options: spirometry flow, spirometry volume, spirometry minute ventilation, and spirometry tidal volume. So the first thing we need to do, we need to set up spirometry flow. So I left-click on this, and the spirometry flow settings window comes up. It's asking me where is my flow data. We're going to output flow data out here to channel 1, but what input is it coming in on the power lab? In our instance, like I said, it's input number 1. It gives us an option for drift correction. If we've done everything we're supposed to prior to setting up, prior to actually recording data, warming up that spirometer, zeroing everything, we should not need to use drift correction, and normally I would recommend not using it. However, you may, if you have a third-party spirometer and it's getting some oscillation in it or something like that, we can go ahead and apply the drift correction here, but normally 99.5% of the time you're not going to have to use it. As I mentioned, with the flowhead calibration here, we have all of the flowhead models. We have presets conversion values already in for them. So if I change it to LT1L, which shows here, they're already installed in the spirometry extension. However, as I said, with researchers, and if you're actually doing, using the spirometer for a research application, you might want to have something a little more accurate, not rely on those preset values. And that's where this custom option comes in. Or we can simply hit calibrate. That will take the same place. So I'm going to go ahead and here and select custom. And you see here this region that I highlighted out here in the flow channel shows up now in this area right here. So if you're using something that you know you injected a known volume, for our specific application here, I'm going to say we're using our 3-liter syringe. So I tell lab chart, okay, it was 3 liters. Here's a flow channel, the change in flow, and here's lab chart actually calculating the proper flow conversion equation from voltage to liters per second. If you have any questions about anything, you'll notice throughout that we have these little hot buttons right here that will take you to the help menu topic for that specific window. I would highly recommend using them. If you get lost at all, definitely click on them. Our help menu, many people have bad experiences when they're using help menus from other Windows programs, say even for Word or PowerPoint, something like that. We try very hard to make our help menu as useful as possible, and the best perspective on it and how to look at it is actually is a paperless manual. So definitely do not be scared of it. It's broken out of topics, and like I said, if you're in some specific region in the software, quite often you'll see these little help menu buttons. They'll get you the specific topic that covers what you're doing. So we've gone and done our calibration. We have our data that we recorded with the flow calibration. We've selected it. We've determined our final calibration formula. We hit OK, and lab chart is applying it. So I hit OK, and you'll see here I'm going to drag out a little digital voltmeter, a DVM, and as I mouse over the data, we are now in liters per second. And that's all you really need to do to actually set up the flow channel. So now that we've set up the flow channel with our known volume of air, we've done the proper units conversion, we're going to move on to calculating volume. Now to calculate volume from flow, it's basically an integral. You could do this with some of the integral features in LabChart, but the Spirometry extension provides a few other options available to us, or that makes them available to us that will allow us to maybe account for some of the common problems, with doing spirometry. So in channel 2, I'm going to set up my volume channel. So I'm going to go down here and left click, and you'll see here in our channel calculations menu we have spirometry volume. Now prior to doing that, I'm going to record some general flow data here, just so we have some data for the actual volume calibration that we're going to do later. Now this data, as I said before, is recorded using a two-way circuit. You would not need to collect this data if you're using a one-way circuit and just measuring expired volume. But for our specific application, we need to account for the fact that if the subject is inhaling room temperature air, and this room temperature air goes into the lungs and is heated, it expands, and if we don't account for it, it looks like they actually exhale more volume than they actually inhale. So we're going to record some data here that will allow us to calibrate for that, or apply a correction factor, I should say. So basically what we want to do, the necessary data is going to be about 4 or 5 tidal breaths, followed by just a normal inhalation and a full exhalation, just to completely empty the lungs. It doesn't have to be a forced exhalation. It just needs to be nice and calm, but fully exhale the lungs. And then we want to go through and do a few more tidal breaths, and then do another full exhalation. And follow that with a couple more tidal breaths. Once we have data that looks like this, and once again, this is only for a two-way circuit. We do not need to do this for a one-way circuit. I'm going to go ahead and left-click and drag. And we'll look at these. Okay, so we have a few tidal breaths, full exhalation, few tidal breaths, full exhalation, few tidal breaths, and this will allow us to do that calibration. It'll become clear later on. We have to highlight like this in order for the spirometry extension to look at this region of data and calculate the correction factor. So as I said before, we're going to make channel 2 our volume channel. So I left-click on the channel 2 title bar, select spirometry volume, and we get the spirometry volume settings window. First thing you'll notice, we want to have our source, which will be the spirometry flow channel. Lab chart already identified it for us, but we can go ahead and change it here if we want to. And then comes this volume correction that we can apply here. So if I check this box, we're allowed to enter the amount of dead space in our flow circuit. Just calculate what's there in between you and the flow head. This is the calculated volume ratio from the selection we've made. By default it's 1, but of course we can apply here our correction ratio. If I hit OK, we've actually applied it. Looks like we might need to make a little bit different selection here. Have a slight bit of drift. If it does not work correctly for you, if you end up getting too much, it still is drifting a little bit, we can go back. All is not lost. You just can't get it to that correction ratio to work properly. You can uncheck it, and just for argument's sake, we'll go here and uncheck it, and you'll see we're getting this strange drift down because it looks like we're expiring more volume than we're actually inhaling, and the integral that we're using to calculate this will be additive. It'll keep going more and more negative as we go along. However, if our volume correction doesn't work correctly, and we just can't get it to work, we can always just kind of go here by force and reset the volume to 0 at the end of each expiration. So if we do that and go and hit OK, no more drift. If for each expiration, you'll see at this point right here, we force it back to 0. I'm going to do a little bit more of a selection here. We'll see if we can't get a better correction value. Do not use these at the same time, one or the other. We'll apply here. There we go. Much better. So a couple breaths before our full exhale, some breaths in between our full exhale, a couple breaths afterwards. You can see we've accounted for that drift throughout. We're getting a nice volume calculation here. So that kind of takes us through setting up both the flow and the volume channels. You'll also see, I'm going to go ahead and grab DVMs for both of them and pull them out, that we are now from volts over into liters per second and liters. So we've calibrated and also done a use conversion over to a unit that actually means something to us for spirometry data. Now we're going to talk about settings. We can access the spirometry settings from the spirometry menu. You see we have about 4 options here: settings, data window, flow volume plot, and report. But of course, we'll talk about these in turn later. However, right now I just want to talk about the settings of how to set up spirometry extension to actually perform the calculations we want out of it. So I left click here. Since we have flow data set up, we can actually choose here what flow channels we want. We can have multiple flow channels set up if we want to, multiple volume, and we can tell the spirometry extension, okay, go look at this one, go look at this channel, etc., etc. We can tell it to whether we want to include non-forced breaths in the spirometry report. Depends on whatever analysis you're using. Up here in the preview of detected breaths, we have all of our controls that are available out in the lab chart, in the actual chart view. They're also available here. We can compress and uncompress the time axis. And this kind of moves us on to our detection adjustment. How does lab chart detect an actual respiratory cycle? It's going to look at a certain percentage of the full range we're recording at. This is where it becomes very important that we set that range correctly before we start recording data, because we have a limited window we can look at here, either 0.01% of full range to 10% of full range. So if we record a really, really small signal with too large of a range, we may not be able to get down far enough with this percentage slider or the setting to actually go in and detect the breaths that we need. Now you'll notice here that, let me get a little spot tool out here for us. Here we're actually detecting something that is not a respiration event. So we need to change our detection settings. And to do that, all we have to do is go ahead here and up the percentage. And if you keep looking at that event, now you'll notice that we no longer have that blue line that signifies we actually have a respiration cycle here. Well, everywhere else where we do have a respiration cycle, we're identifying them correctly. You'll also notice here forced expiration threshold. So if we're doing a FEC test or FEV1, we want that sort of thing. We can tell the spirometry extension here, okay, this is the threshold you're supposed to use. So 2 times the average volume that we're calculating. And that's how we would kind of move along and set up the spirometry extension. And this stuff all plays into what's put out by this spirometry report. So we've set things up here. There are a few channel calculations available to you, as I mentioned before, with the spirometry extension. If we left-click down here on channel 3, we can actually do minute ventilation. If I left-click on that selection, the channel calculations menu, all I have to do is select the flow data that I want to read this from. Obviously, default for minute ventilation is going to be 60 seconds, but if you want something other than minute ventilation, 2-minute ventilation, half minutes, you can go ahead and set it here. And of course, we have our hot button that takes us out to the actual help menu topic for this particular part of the spirometry extension. And you can see here, if I pull a DVM out, minute ventilation is pretty steady here. After 1 minute, we change. Okay. Last but not least, we left-click on this on channel 4, and we can select spirometry title volume. Once again, to get there, left-click on the channel title, and you get the channel calculations menu will pop up for that channel, and of course we can set up spirometry title volume. Left-click on this, select what flow data I want to use. The lone option here is source has expiratory flow only. Once again, if we're using that one-way circuit, or just measuring expired flow, we want to check this. However, our data here is from a 2-way circuit, so we don't check this box. I hit OK, and you see now, go ahead and pull a DVM out here, we're getting our tidal volume for each breath. As I mouse through the data. So those are the channel calculations that are available to us. The other options, as I mentioned before, if we go to the spirometry menu, drop-down menu here at the top, I can open the data window or the flow volume plot. So I'm going to just select one of our full exhalations here, since they're similar to a forced exhalation. We go spirometry into data window. And this gives us a nice graphical representation of what happened with this full exhalation, or if we have a forced exhalation, what's going on here. Pressure, peak inspiratory flow here, peak expiratory flow, forced vital capacity, forced expired volume at 1 second, so FEV1 right here. Just different things that you're going to want if you're doing spirometry experiments. And also kind of a note here, we can print this data window, just put it out as a sheet of paper out of our printer. We can also copy it and paste it into a Word document, into a PowerPoint presentation. So if you're actually writing your paper on this, we can go ahead and actually insert this image into it, and you can just have this great analysis and actually have it in your paper as well. And that's basically just copies it into a simple image format. Next, I'm just going to highlight some tidal data here. Actually, we'll include one of our full expirations. And we can go to the flow volume plot. So we can see our total breaths, and then we see our full exhalation. This will not occur in real time. As you see, I had to make a selection for this to happen. But we can go in here and look at it. Another thing that you could use if you wanted actual real-time population of this would be the XY window, which can be found underneath the window in XY view. And we could go ahead and actually have an XY plot of flow versus volume if you wanted that to populate in real time. Once again, with the flow volume plot, we can print it. We can also copy it as an image and paste it into another document. So we go ahead and select some more data here. And last but not least, we'll talk about the spirometry report. So it can actually put out the actual values that you're going to want to see. Number of breaths we've identified. What's the duration of this selection? Expired volume for non-forced breaths. Average tidal volume for non-forced breaths. Average VT, etc. And of course, we can export this as a comma delimited text value, a .csv file. And of course, here if you look at breath 1, forced, we can see everything that we need for that specific breath. How many breaths have we selected over? So a great way to go ahead and pull that data out. That's important to you if you're doing spirometry. This kind of takes us to the end of the spirometry extension. So that's everything we're going to cover today, and I'd like to thank you for joining me for another one of our series, and have a good day.